So let me do my best to talk intelligently in this. First, I'm Matt Benjamin, and my current title is Program Director for Ceph Object Storage within IBM. I was formerly the Ceph Engineering Manager or Senior Engineering Manager for the same thing in Red Hat. Daniel Gernovich has been my colleague since I guess 2012. He joined my company CoreFS and another precursor company working on NFS and some other things, and joined Red Hat with us in 2015, and has been steadily on the RGW team since that time. Did not need it. Oh wow, I got double mics. Okay, I see. Anyway, so the talk I'm going to follow the strategy of this talk. This was originally to be given by Casey Bondley, who's our upstream product technical lead. We're going to capture it. Ceph object storage capabilities, roadmap, future plans. I'm going to follow that to the letter, which will hopefully help with the fact we don't have the slides up, but we'll make something and distribute it somewhere. First of all, what are its capabilities? Ceph object storage, or RGW, is high fidelity S3 and Swift compatible HTTP object storage layered on obviously Ceph Rados clusters. Its main capabilities are scale, capacity of hundreds of petabytes in a single cluster in some cases, namespace of hundreds of thousands of S3 Swift buckets or Swift containers. Buckets can be loaded up to at least 500 million objects, and our target would really be closer to a billion, but that's conservative. With dynamic bucket index scaling, which we've had for the last 4 or 5 years. The key services that our S3 implementation provides: flexible user management, including as in the most recent versions with OpenID Connect, OAuth 2, and SDS. Lifecycle transition, active-active asynchronous replication is probably our biggest signature feature at this point, but also a whole lot of policy for my bucket policy, session policy, role policy, etc. Significant recent developments. So heading into the more recent stuff, there has been in the last 2 years a massive refactoring and rewrite of the multi-site replication capabilities for scale and robustness. You heard a talk from Bloomberg's folks earlier this morning about how they helped us operationalize that, but it was an enormous piece of effort, and with several pieces. I'll get into a little bit more of it in a second. But an implementation of S3 Select, which is structured data operations on top of layered on S3, and enables predicate pushed on some other things. We'll talk a little about that tomorrow. A very significant refactoring of the internal APIs of RGW called Zipper, and Daniel will talk a bit more about that. SSE S3 managed encryption, so we now support all of the Amazon compatible encryption APIs almost completely fully, and something called OMAP offload. I'll just say a large amount of computationally expensive operations in RGW implementation were moved out of our index storage called OMAP into these new into queuing operations on Rados. So that's a pretty big scalability change, and it especially affects both garbage collection for out-of-line deletes that RGW does, and also multi-site. In Reef, we add more S3 Select capabilities, a full-featured Parquet implementation for Parquet structured tables, but also JSON, wherein we have a very capable JSON unstructured query implementation with a lot of flexibility. That should be pretty interesting to experiment with. End-to-end tracing. This is something we've been working on in Ceph for something like 10 years, but we finally will have end-to-end tracing with Jaeger, meaning that you'll be able to originate Jaeger traces in an RGW, trace operations all the way down to an OSD and back, and see them in the trace collector as a unified round-trip set of spans. Finally, something that we unexpectedly had to do, due to an index corruption bug, we also implemented index recovery for both versioned and non-versioned buckets. That's a pretty important schema improvement we're glad to have had, and that'll be in Reef. You want to take on some of the 2023 roadmap pieces?
Sure. So in the core, one of the big changes we're going to do is in 2023 and later is to update our coroutines to C++ 20 coroutines. Currently, RGW has its own coroutine implementation. and moving to the standardized one should be a fair amount of improvement in a number of respects, including maintainability. This involves also changes to Rados and Objector, which we're calling Neo Rados, and considerable changes to RGW. We're threading something called an optional yield throughout everything, so that makes everything basically potentially asynchronous using these coroutines. We have a bunch more multi-site replication enhancements that are coming. We're working on parallel sync and particularly sync fairness, so that we can have 100% fair sync spread across all your RGW instances. And we're working for bucket index OMAP offload, so the OMAP offload that we talked about before, extending that to bucket indices. We're working on S3 inventory, which is sort of a bucket listing offload. It's a pre-generated bucket listing that you can use for administrative stats and things like that, if you don't need absolute perfect real-time results. A big one is D4N. D4N is a caching layer that's being developed in cooperation with the Massachusetts Open Cloud group of universities. This will allow the ability to instantiate a number of different potential caching algorithms and a number of different storage systems for various types of caching. And that ties heavily into Zipper, which we'll get to in a minute. We're working on Elastic, and we're going to do, in particular, we want to do scale analytics workloads like Hadoop and Spark. There's another talk on this tomorrow, so there'll be more on that. And then ongoing is our Zipper work. This started a couple years ago, and what it is it's an API that cuts entirely across all of RGW just below the op processing layer, so just below S3 and Swift. And it adds a replicable API into that layer, and then modified all of the code underneath to use that API. So that code then becomes the Rados store. And that store can now be pulled out and replaced with another one that will allow you to do S3 over any arbitrary storage you want. The reference implementation we did was over a local database, SQLite, and that's called DB Store. We had contributed 2 stores, one on DAOs and one on Motor. And there's work on another store that is on top of a POSIX local file system. In addition, because the API is the same on top and on the bottom, you can slot filters in between that use that API and pass things down and then back up. And so we have a prototype filter layer that passes things down that you can use for implementing other filters, and D4N is being implemented as a filter. This allows you to intercept any operation after it's been decoded as being S3 or Swift and turned into the RGW internal structure. And you can do anything you want to that operation on the way down, and you can do anything you want to that operation on the way back up. So if you want, you can say, nobody can ever delete anything. And you can intercept all the deletes and just return error. And nobody will ever be able to delete anything. And the way we implemented the filters, because of the base filter classes pass through, you only have to implement the actual methods you care about, and all the rest of them will automatically pass through to the layer below.
Right. So yeah, so the caching piece is kind of a complex thing, but I'll talk more about in our talk tomorrow. I mean, hopefully, Kyle and I will talk a bit more about the interplay of those things together. But then future plans stuff. I think we got to that point, right?
Yeah,
I think we did. So things we're going for, and some of them are already prototypes, and so you can begin exploring, looking around upstream and how they work. New front end protocols is the direction that we're taking. We've always had multi-protocol. We had Swift and S3. That's a unique value we've had historically. We're going in 2 different directions at the moment. HTTP3 Quick is one of those. That was kind of inspired by S3A for us initially, but it has been, obviously Quick is becoming a very rapidly rolling snowball, and it has things to offer, both very scaled HTTP workloads in a data center. That's where I think we think of it as most important for us. where you might have to have hundreds of TCP, HTTP, TCP connections to saturate, for a Hadoop cluster, for example, to saturate an S3 instance, or many times that, many more, maybe triple that or more, to satisfy like a Hadoop cluster of the typical size we scaled to in I don't know, even in 2018. You might be able to do that with a much smaller number of quick sessions, and over a wide area. Quick off has another set of advantages. We see now there's an experimental prototype by Casey Bodley available now in the master, the main branch of Ceph. We're also another protocol front end that's being worked on now is Apache Aeroflight. That is an object-based protocol, but it comes from the Spark, from the Apache Spark development environment. It's kind of the next generation internal prior protocol, data exchange protocol within Spark. And it's part of a new group of connectors, connector V2 it's called. And our goal is to be able to go beyond S3A for different kinds of workloads in application platforms like that. For analytics, AIML applications is our main idea. And also, it already has, because of those application areas that it targets, there's already an extension of Apache Aeroflight called Flight SQL, which is a data description. As you might imagine, it's a SQL data extraction and summarization extension, a little bit like, but more powerful than our S3 Select, and we're developing a unified extension of our S3 Select engine and Flight SQL in a future version. You can experiment now with Aeroflight to get objects and put them into cache and to do a few other things, but the Flight SQL will be coming probably in 2023. There's been a bunch of work by Yuval Lifshitz, and I should highlight him in particular, on dynamic scripting inside of RGW. There already was Lua scripting in several other parts of Ceph. We incorporated it into RGW, and we're building on that to do more things. And I'll talk about a couple of them. But one is there's an experimental scripting you can do now, but you have to be sort of a site administrator to use it. We'd like to take a next level up and go to safe scripting so that ordinary workload users could inject scripting into the server and do interesting stuff. Some of the things we are thinking about now are tracing. We could turn our tracing system into a conditional debugging environment including for complex workloads like multi-site sync where something is going wrong and you want to inject a discovery of exactly what's happening and maybe even correct it. And also with Zipper, Daniel has proposed that we could build actual completely dynamic Zipper stacks or filters, and without changing lines of server code. We'll be able to dynamically load such modules that are native code, but with this you don't have to do that. I think that might be. Is that the end of it? No. We're doing tiering enhancements now. Our product management within IBM is very keen on enhancing the tier to S3 capability. There's an ability now to transition to use obviously it's IAM S3 transition policy to tier data to for example our mode S3. We keep a stub of the optionally, but typically you would pointing to what that data has been tiered, but we can't currently recover it. We want to include the ability to do that by hand as Glacier does, but also have maybe some sort of automatic tiering policy that could be developed or injected perhaps with Lua to control that sort of thing. We're going to do archive zone enhancements. These are kind of comprehensive, and it's probably going to be a couple of years before this is really usable. But we have our current data layout has a number of advantages. It goes direct to a Rados object to get on a getter head request. That's one of its advantages. If you want to store a large amount of data, which is I don't know if you guys don't know what archive zone is. Archive zone is a kind of an extension of the multi-site replication, wherein specific zones collect a lot of data, perhaps many versions of a bunch of objects, but don't ever delete them. That's kind of a crazy idea. But with data reduction, deduplication in other words, we'd be able to make that more tractable. And so we're looking at a constant addressable storage. I guess we'd call it a bucket layout for maybe 2024, 25 timeframe. And there's going to be. I'll put in one more piece. There's another aspect of we've talked a lot about and at least some about the multi-site enhancements that we've done to this point. One that might not be salient to most people is that we have a single master or single origin metadata model. There has to be a primary zone Even though replication is active and peer-to-peer most of the time, for purposes of creating new buckets and creating new users, there's a nominal primary that has to receive those updates first, and we'd like to eliminate that with a consensus-based protocol, and so that's going to take that's a pretty big change. We'll probably want to separate it from the representation of metadata and treat it like an update transaction type of thing. But it'd be more like efficient Paxos or some type of technique we would use because it's wide area. So questions on that? Questions are, and then someone's got the mic there, and if you have questions about that kind of about the roadmap or things you'd like to see people do with RGW, we'd like to hear about it.
So you were talking about archive zones. This is interesting to me, but also you mentioned a feature about filtering, going down and up in the stack. So is there any chance for having object packing sometime in the future? Yes.
Yes, I should have. Sorry, object packing is much needed. As you know, for accumulating smaller rights of smaller objects. The D4N cache project that was done by Messip and Cloud includes a partial prototype of object packing that's layered into the D4N system, and then a bunch of benchmarking and other analysis was done. It doesn't have all the pieces needed to go live. So our D4N prototype, which we hope this to be a 2023 end of 2023 Q3 Q4, we're going to have D4N in an MVP form upstream. There's an entire out of tree prototype by Boston students, but that will not be there. There's a need to do a couple more things. There's a need for an in bucket or in system index extensible index format and some other stuff. But there is an intent to do that. It's probably I should have probably put it in here. It's probably a couple years away, but we do intend to do that.
Is there any plan for a fairness issue fix for data sync? What's the status?
Yes. Well, the integration of sync fairness with data sync should be almost identical to the metadata sync. So it's taking more weeks than I wanted to merge it, but I'm thinking with the next 2 weeks, I'm hoping to see the metadata sync fairness come in, and I don't think it should take more than 4 to 6 weeks longer than that to get data sync in. Although it might take longer to fully. It might take a bit. There'll certainly be a PR at that point. It's almost the same conceptually though.
Thank you. I'm just wondering how the zipper-based RGW, standalone RGW, will compare to MinIO.
I mean, it should compare to MinIO very similarly to how RGW compares to MinIO because it's RGW, right? I mean, performance characteristics will depend on the capabilities of your storage system that you're backing it with. So if you're backing it on, super fast NVMe, obviously it'll perform really well. If you're backing it on 5400 RPM spinning drive, maybe not so much.
It's not the same code base, and right? So it's architecturally different. It's more comparable to what I understand to be their gateway architecture, which someone told me a couple people told me over the last few weeks is going away in some form. But it's a different architecture, and it's a different stack. It'll have support for all of our features, and it's all. I mean, it'll be all synchronous in native code. They're synchronous in native code. It's not intended as a MinIO killer, but it's intended to cover enough of the space that you could use it, that you could experimentally use it for that. We'd like to see developers be able to develop to rapidly assemble enhancements to RGW, and we'd like to be able to put Ceph object storage in places we couldn't put it before. But we'll have to see. I certainly aspire for it to be very useful in small form factor.
I mean, this is something we plan to productize, so it's not just sort of a one-off experimental thing.
Regarding the documentation and the documentation updates for multi-zone groups and whatnot, is the documentation already up to speed with all the changes? Because I think it's one of the most
Zach?
complex pieces to actually get right.
People have worked a lot on it. It is continuously improved. I think it's not bad. Zach might disagree. There are brand new sections for new capabilities. We have, I didn't mention it here, but maybe I should have. There's a lot of things happening from the Pacific to Reef timeframe. We implemented we productized Yehuda Sade's work on essentially we call it on basically per bucket replication, but it's basically more of the cross-region replication capabilities and some of the notation on top of the multi-site framework, and that has a great deal of new documentation. There's new policy and other things you can do to control where data can be replicated, which buckets can replicate where, and that kind of thing.
And for sure, there's been hundreds of doc PRs coming across, so documentation is dramatically improved, whether or not it's completely perfectly up to date.
Yeah, I'm not sure it's good enough, but it's much better than
And it will continue to improve over the next few months as the doc team is working extremely hard on RGW docs.
It's about the RGW standalone. Are you targeting developer desks or even very large POSIX file systems for HPC centers?
So yes, I mean, one of the targeted deployments is spectrum scale. So yes, we're targeting very large deployments, but also developer level deployments.
For this bucket index OMAP offload, is it going to be similar to this FIFO thing? You're going to, it is? Okay.
It is the pipe.
Okay, and about filters, so how do you envision compilation? So it will be out of tree compilation for RGW filters, or it would be in tree?
So currently filters are compiled in tree, but very quickly, as a matter of fact, already, we've basically hit the limit of how many we really want to put in the tree, right? So very, very soon there will have to be a project to do out of tree. I'm kind of waiting on that until after the loadable modules gets merged. But as soon as that's merged, we will do a project to do out of tree compilation.
I mean, the dynamically loadable, the loadable modules basically is that, sort of.
It's a way of getting them. But in order to build, you currently have to be in tree, and so we'll need to be figure out which headers we need and all that kind of stuff to be able to set up a framework to let you build out of tree. But yes, that is definitely a plan, is to allow building out of tree, because we don't necessarily want to have hundreds of filters in our Ceph code that we have to worry about building in our CI and all that kind of stuff. So. And in fact, maybe we may end up even setting up an external repository for contributed filters.
Will the filter be, or can I have them transparent, so the operation that goes in through the filter directly goes through, and I can basically duplicate it?
There's a filter that does that.
Great.
There's a trace filter. It's experimental. I mean, yes, you can do it.
Can you talk more about the tracing thing, which will help develop more issues like you say?
Well, if you look in, if you're familiar with the Jaeger tracing project that has been, and it had precursors in RGW and Ceph too, but there's Zipkin and a couple and LTTNG, but the Jaeger is kind of Zipkin or yeah, there was another name for it but with a lot like, but it's Jaeger tracing, and there are a group in there right now. There are static trace points, and there is some Lua enablement of those trace points, so you can insert additional data into a trace point span as extra data. I think with scripting and some other capabilities, we could enable you to add Lua scripting code, which enables trace points or perhaps changes the data set that gets fed to a trace point, or could make it even completely scripted, even more dynamic. It could look for particular flows earlier in the requests, processing, and cause different traces to be emitted based on that. So you could look for particular misbehaving or unexpected behavior and get more data on it through the trace flow.
So one of the things, if you were at the Bloomberg talk earlier, they complained about the amount of logging and wanted more granular logging. This would enable that through the tracing framework. You could have detections, detecting scripts at runtime that said, if this event happens, trigger tracing on it, and it'll trace all the way through.
So how do we insert the tracing points? Is it which file, which line, or something?
Right now right now you have to. There are like 5 hooks, and you can put a static Lua file into place to do that. I think there would be APIs and particular places you could insert your code and probably into a stack of such hooks and things like that. I don't think it probably won't be. There'll probably be specific places you can do that. They'll be similar to the trace points that are in there now. We're not going to be able to update pick any place in the C++ code to do that, but there'd be a gradual evolution of good places to hook scripts. Well, a kind of static version is. I mean, you can use RWW admin to push, I think, 4 or 5 different hooks with Lua code, but you obviously have to be the site administrator to do that. Right now, a Lua program is unsafe inside the server. It needs to terminate any loop that it enters and things like that. We'd like to. One of the things I was hinting at was we'd like to have an instruction counted model or something along those lines that would allow us to guarantee that users can inject code into the system, but not break it.
Yeah, so pretty much all of what we've talked about in this, most of what we talked about in this is future work. So some portions of some of it may be available now, but a lot of it is still future work.
Following on from the Bloomberg talk, would the S3 inventory help compare multi-site replication if it's in a dynamic, if there's lots of data running through it?
Yes,
Basically, probably.
So far as
within the time granularity of 1 day or 1 week.
Yeah, insofar as bucket listing itself would help, right? Because the inventory is just bucket listing, but done in the background for you, on a low granularity.
But there's a lot of things that probably is a good idea. I can imagine it being anyway. But there's a lot of work for in the Spark community and other places. There are application workflows that make use of that, and bucket listing is relatively expensive, and doing it once and reusing it many times, and then doing it and offloading it could be a big accelerant for a workload.
Anything else? All right. Thank you for coming.
Yeah, thanks very much, folks.